All right, so where we left off was solving by quadratic methods. So other quadratic methods besides just factoring, right? And so we have the square root property and the quadratic formula. So let's go ahead and try a few here. So we again, so this will be number 1. So find all exact solutions over the period 0 to 2 pi. And again, we can always change the period. It doesn't have to be from 0 to 2 pi. I can make the start and the stop at any number. So we want to pay attention to that. But for right now, we'll keep it simple. So 4 sine squared of x minus 3 is equal to 0. So using the square root method, so I'm just going to add 3 to the other side and then divide by 4. So I get 3/4. I'm going to take that lovely square root. I'm going to square root both the top and on the bottom. So I'm going to get sine of x equal to plus or minus the radical of root 3 over 2. So basically, I want both the positive and the negative radical 3 over 2. So I'm looking at quadrant 1, 2, quadrant 3, and quadrant 4. So all of my answers include all of these. Pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3, right? So we test out one of them, do a quick little check, right? 4 sine pi over 3, right, squared minus 3 is equal to 0. So pi over 3 squared is root 3 over 2. Then we're going to square that. So 4 times 3/4 minus 3. The 4's are going to cancel away. 3 minus 3 does, in fact, give us 0. Right? What happens, though, if the problem is quadratic? Right? That cannot be solved by square rooting. It has to be used the quadratic formula. So find all solutions over 0 and 360 to this problem, and 3 cotangent squared theta minus 3 cotangent minus 1 is 0. And we're going to round to the nearest 10th, right, when we solve for this. All right. So first things first, we want to see if it's factorable. So are there any two numbers that I'll be able to multiply to -3 and add to -3? And the answer is no, it is not factorable. So what the first thing I'm going to do is I'm going to say let x equal cotangent of theta. So this will now become 3x squared minus 3x minus 1 is equal to 0. So I'm just taking away what makes it look challenging, right? So I'm going to plug, so here's my A, here's my B, here's my C into the quadratic formula. So x is equal to, so negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So this will become 3 plus or minus 9 plus 12 all over 6. So 3 plus or minus 21 over 6. But we're not solving for x, right? We wrote a let statement right here. We said let x equal the cotangent. So what I need to do is I need to replace it. So I'm going to say the cotangent of theta was equal to 3. And I'm going to break it up into two problems at this point. So 3 plus 21 over 6. And the cotangent of theta is 3 minus root 21 over 6. Now, I don't know about you, but we don't have a cotangent button on our calculator. What we do have is a tangent. So I'm going to flip my fraction. So 6, 3 plus root 21. And I'll flip my fraction over here. So 6, 3 minus root 21. Then what I'm going to do is I'm going to apply the inverse. So basically I'm going to switch these two things around. So this will become the inverse of tangent, and then 6 over 3 plus root 21. And then over here, the inverse of tangent, and then 6 over 3 minus root 21. Okay, so I want to find all my values. So I need to pull up my calculator. Okay, so first thing I need to do is check my mode. I am in the correct mode for degrees. So quit out of that. So I'm going to say the inverse of tangent, and then I need 6 to be in the numerator. So this will be 6 divided by, but I need the whole thing to be in my denominator. So I'm going to open my parentheses up one more time. So 3 plus root 21. And then close for my denominator, close for my entire fraction. And this is going to give me about 38.35. So let's round this up to about 38.4. So this, we change this color to about 38.4 degrees. Okay, what do we know about tangent? Is that tangent's period, so tangent's period is the length of pi, or 180. So all I have to do is add another 180. So if I add 180 to this, so plus 180, I'm going to get 218.4. So I get my second answer. So I get 2 answers. So 218.4 degrees. So there are my 2 answers right there. All right, I'm going to go to my second one. So I'll move this over so we can see it. So again, inverse. Actually, what I'm going to do is I'm going to scroll up, and I'm just going to change the plus sign to subtraction sign. Please make sure you're using subtraction instead of the negative sign, because that will give you a different answer. And I'm going to get negative 75.2. So theta is equal to 75.2, but it's negative. Uh-oh. Here's our problem. Negative 75.2 is not in our range. So I need it to become in our range. So what I'm going to do is I'm going to add 180 to it. So if I add 180 to it, I'm actually going to get 104.8. So this is actually, so I'm going to add 180, so 104.8 degrees as one of my thetas. And if I do another add 180 degrees, I will be at 284.8. So 284.8 degrees. If I add another 180, I know I'm outside of my range, just like if I added another 180 right here. So my whole answer, all of my thetas, could possibly be 38.4 degrees, 104.8 degrees, 218.4 degrees, and 284.8 degrees. Now these are all rough estimates, so for checking purposes, you're never going to be able to plug these in exactly and get this equal to 0. We'd be able to plug this in exactly and we'll get it equal to 0, but once we start with our decimals, then we run into some issues. Okay, we have one more type for solving, and these are solving by using the trig identities, right? So last one, okay, so solve by using trig identities. So again, here's some steps. So try using our identities to get the trig equation in terms of the same trig function, especially if I can't factor something out. Or sometimes it's helpful to do this. It might or may be helpful to square both sides. Write this in red. If you do this, you must check for extraneous solutions. Okay, this is really the only type of problem that you 100% must check, is if you square both sides. All right, so this is the only one where you must check all of your answers for extraneous solutions. Okay, so let's try a few right now. So we're going to find all your solutions from 0 to, actually, no, we haven't done radians in a while. Let's do radians. So 0 to 2 pi. So cosine squared of theta minus sine squared of theta is equal to 0. So again, maybe you see this as a double angle. There are other ways that we can solve it. Right now, let's focus on getting rid of our trig. So I'm going to go ahead, I'm going to replace all of this with this guy. 2 cosine squared of theta minus 1 is equal to 0. So now I don't have to worry about a 2 in front of my theta. So I go ahead, add 1 to both sides. I'll divide by 2. So I'm going to get cosine squared of theta is 1 over 2. Take the square root. So plus or minus 1 over root 2, which is the same thing as root 2 over 2. So I have some answers. So where am I going to be? Quadrant 1, pi over 4. Quadrant 2, 3 pi over 4. 5 pi over 4 for quadrant 3. And then 7 pi over 4 for quadrant 4. Okay, again, I didn't square both sides, so I don't have to worry about checking, but I can plug it in. If I plug in pi over 4, this will be the root 2 over 2 minus root 2 over 2 is equal to 0. So again, 0 is equal to 0. Let's try another one. Sine of x is equal to the cosine of x plus 1. So for this problem, what I notice is that I can't really do a whole lot. If I move something over, it's not really factorable. And in order for something to change, in order for this to become cosine, I need this to become squared. So that's exactly what I'm going to do. I'm going to square both sides. So if I square both sides, I'm going to get sine squared of x, and then this is cosine of x plus 1 times cosine of x plus 1. I'm going to go ahead and I'm going to change this now to 1 minus cosine squared of x. This is going to give me cosine squared of x plus 2 cosine of x plus 1. Let's set this equal to 0. So 2 cosine squared of x plus 2 cosine of x. The 1's cancel out. I can divide everything by 2. That's not going to change my problem. So 0 is equal to cosine of x plus, or squared, plus cosine of x. I'm going to factor out a cosine, and then I'm going to set them all equal. So cosine of x equals 0, cosine of x plus 1 equal to 0. So my answer for when it's 0, oh, I didn't even say what we should have it. Let's do radians again. So 0 to 2 pi. So that's my answer. So we'll say x is equal to pi over 2 and 3 pi over 2. So we got 2 possible answers. If I subtract here, cosine of x is equal to -1. There's only one answer at this point. It's pi. But what did I say? We said we must check these answers. So here's our quick little check. So sine of pi over 2 is equal to cosine of pi over 2 plus 1. So sine of pi over 2 is 1, and this is 0 plus 1. So that worked out. Sine of 3 pi over 2 is equal to cosine of 3 pi over 2 plus 1. -1 is equal to 0 plus 1. Notice this one doesn't work out. All right, sine of pi is equal to cosine of pi plus 1. So 0 is equal to -1 plus 1. So 0 is equal to 0. So our answer for this one is just pi over 2 and pi. Right? So again, these are the ones that we must check.